today we shall be discussing the differences between tubular battery and lithium battery. So, tubular battery, let's consider 10 kilowatt lithium battery and also 4 pieces of tubular battery. So, let's compare the differences and know which one is the best when using. So, when you connect this battery in series, these 4 batteries in series, it will give you plus minus, to give you 10,560 watts. That's total wattage. It is 12 voltage times 4 times 220 to give you 10,560 watts. So this will give you total voltage of these 4 batteries. So when you cross-check this, when you cross-check the total voltage of this lithium battery, you'll be getting 208 amp times 51.2 volts. The nominal current of this lithium battery is 208 amp, while the nominal voltage is 51.2 volts. So how we come about this voltage is by dividing. Maybe if you want to know the current of 10 kilowatts lithium battery, if you want to know the current, you say 100,000 G's, 10 kilowatts lithium battery divided by 1,000 divided by 48 volts, because the voltage of the lithium battery is 48 volts. So this will now give us 10 times 1,000 over 48 volts. You now get, after everything, we get 208 amp. So that's how we get this amperage. So by the way, when we clean all this thing, so I just this thing so I can be able to know how we got this 208 amp. So, but it's not necessary. So you're only interested in the amperage, which is this current. So let's proceed with our main topic. Then to get the power of this lithium battery, we will say 208 amp times 51.2 volts. You will get, punch it, you will get 10.64.9.6 watts. This is what you will get. So if you check the final value of the batteries, you will find that both of them are the same value, 10,000. So, but considering the depth of discharge of battery, this tubular battery, you can only discharge it 50%, 60%, and also 70%. But the depth of discharge of lithium battery is 90%, 95%. So, considering using 70% discharge, what this simply means that you cannot use this battery till the battery is fully discharged. Like, you will not use this battery till the battery goes off. that when using this battery, if it is 48-volt system, the highest voltage you will get in this battery when it's fully charged is 42 volts when fully charged. When fully charged, the highest voltage you will get in lithium battery is 54 volts. So if you start using this battery will be going down from 50 to 53 to 52, 51, 50, 49, 48, 47, 46. So when the battery gets to 46 volts, you quietly off the system so that the battery will not off by itself. So if you allow this battery to off, or if you allow the system to off by itself using this battery, it will get a time that the battery cells will be weak, and the battery will not be able to contain or last longer the way it used to be when you buy it new. So it is advisable to off the system at 70% usage, or 50 or 60, but let's use 70% depth of discharge. So when this battery gets to 46 volts, you off it so that it will not damage the battery cells. So let's proceed. I have to clean up this illustration. So back to where I've stopped. If you check here, you see that the battery voltage is 10,560, and for the lithium batteries 10,649.6 watts. They have similar or almost the same voltage, just little bit difference at the back of the values. So let's consider 70% discharge. 7% discharge usage of this lithium battery will be 10,000. Will be 7% discharge. 7% DOD, depth of discharge, it will now be equals to 10,560 watts divided by 100 times 70. So if you point this thing, you will get a total value of punch it, okay? Value of 7.392 kilowatt hour. So let's come to this side. Consider 90% discharge of this lithium battery. 7% discharge is depth of discharge, DOD. You will get 90 times 1064.6 watts divided by 100. So you will get 0.6, you will get 9,584.6 watt, yes. This is what you will get. So if you check this thing now, you will see that the depth of discharge of this battery is 7.3.9 blah blah blah, and this one is 9, as you can see in the figure. So if you divide all this by 1,000, you will get 9.5, yes, which is approximately 9.6 kilowatts hour. So this is the power you can be able to use with this lithium battery. You can use it from 50% down to 90%, and battery can still serve you well. So but in this lithium battery, you can only use it 70%. So if you check the equivalence of this, so out of 10,560 watts of tubular battery, you can only use 70% of it. So the only voltage you can use out of it is 7.39 kilowatts out of 10,560 watts. You can only use 70%, which is 7.4 kilowatts approximately. So in lithium battery, you can only use 9.5 kilowatts out of 10,649 kilowatts. So from this, you can notice that you can use your lithium battery almost 100%. So while your tubular battery can only use 70% of it. So tubular battery is the best.